Hello friends, in today's video I am going to show you how you can control your water pump from anywhere in the world, turning it on and off simply by sending an SMS. In this project we have used a GSM module, an Arduino Nano and an LCD display to show the pump's real-time status. A serial debugging features is also included. The most exciting features is the authorized number and pin protection, which makes your projects completely secured. Alright, then let's not wait any longer and dive into the whole project step by step, starting from the code to the circuit diagram and PCB design. Before we begin, just a quick note, you can download all the necessary file, the Proteus project file, PDF file for the circuit diagram and PCB design, and the source code from the Google link in the description below. However, to get the code, you have to like the video, leave a comment and share it on any social media platform. Then you must send a screenshot of the share to my WhatsApp by scanning the QR code shown on the screen. After that, go to the code download link and send a request. Then will you get permission to download the code. First, let's look at the key feature of the project. You can control the motor, turn it on and off simply by sending an SMS. Since it's a GSM based project, it does not require any internet connection. It features authorized number control only, which means the system can only be operated by a single specific phone number. It also features pin protection for changing the authorized number via the keypad. This means that while you can use the keypad to update the registered number, the process is secured by a pin. You must enter the correct pin before you can assign a new authorized number. Change pin via keypad. You can also change your pin using the keypad. Of course, to do that, you will need to know your old pin first. Alert on unauthorized access. If any attempt to control the motor by sending an SMS from an unauthorized number, the system will immediately send an alert message to the authorized number. This alert will include the mobile number from which the unauthorized attempt was made. The hardware includes an LCD display that shows the motor and SMS status. This means you can see the motor current status, that is on or off, directly on the display. A 4x4 membrane keypad has been used. SMS feedback for every action. This means the system notifies the authorized number via SMS about every event. Alright friends, you will see the two features listed below, power and battery monitoring. I want to let you know that these have not been added to this current project just yet, but they are coming very soon. I will be creating a new hardware and software design specifically for them, which will add the ability to monitor the power and battery status. Another upcoming feature is internet control. In that case, you will be able to operate the motor using a dedicated smartphone app, which will connect over the internet. Dear friends, at this point we will discuss the hardware of the system. Here a custom motherboard has been designed which integrated several different components. It has an onboard power supply. This serves as our main logic board. This is the GSM module, specifically the SIM800L. A 16x2 character I2C display has been used here, and finally a keypad included for input. Friends, with the keypad you see here, we can change the authorized number and pin. It can also be used for many other tasks. Now we will discuss the circuit diagram. Friends, here in the Proteus design suite, you can see a diagram where an Arduino is used as the main logic board. A buzzer is also included. A power supply is used here where 5 volt is reduced to 4 volt using 2 diodes. That means we can't directly provide 5 volt to the GSM module, so the voltage has been slightly reduced. There are 2 buttons here. These buttons have not been used for any function. I kept them in case they might be useful later. Here an LED indicator is connected to the digital pin 6 of the main logic board. An I2C port has been assigned for the display, and here for the GSM module, if you follow the entire diagram and connection everything properly, inshallah your project will work successfully. Here the keypad connection is shown. It clearly shows which row and column are connected to which pins. Here you can see R1234. Just like this, you can see R1234, C1234 and again C1234 show here in the same way. Here the display connection is shown. The TX and RX pin are used for data communication with the GSM module. SCL and SDA are used here for I2C communication, that is for data communication with the display. Now let's talk about the PCB design. Friends, the schematic diagram we show just a while ago, based on that a PCB has been designed here. All the main components are basically connected on the PCB. If you want without make a PCB like this, you can also do the same project on a Vero board or project board. Now we will talk about the code. Friends, here you can see the code inside the Arduino IDE. I have added the download link for the code in the description. You can download the code from there according to the condition. And here, friends, the serial debugging is shown. Now it's not possible to explain every single line of the code because it's quite a large topic and it's really not possible to cover that in this video. It took a lot of time, effort and dedication to successfully run this code. And finally, a complete project has been built for you all, which contains total 352 lines of instructions. Friends, now we will work with the practical hardware where I will first show you how to change the authorized number using keypad. First of all, to change the authorized number, I need to press the A button on the keypad. Friends, when this button is pressed, you will see enter pin displayed on the screen. Now if I enter the correct pin number, it will be able to access the authorized number change option, but if I enter the wrong pin, I won't be able to enter. First try entering a wrong pin and see what happens. 1 2 3 4, as you can see it say pin don't match, which means I don't enter the correct pin. I am trying again for the second time and press A once more. After pressing A, I will enter the correct pin number. The default pin used is 4 zeros. So now I will press 0, 1, 2, 3, 4. After pressing 4 zeros, now I have successfully accessed the authorized number change option and the display is showing enter new number. I will replace the previous number by inputting a new number. Now we will press the hash button, but we need to keep in mind while entering the number. The number we are entering must be entered along with the country code of the country. Now when we press the hash button, the number will be saved into the EEPROM. Friends, as you can see, the number has been saved successfully. Now let's see how to change the pin number. To change the pin number, we need to press and hold the B button for more than 3 seconds. We are doing the process now. Friends, you can see on the display it say enter old pin. You have to assign a new pin by using the old pin number. We already know the old pin number, as we saw earlier, it's 4 zeros. So let's input 4 zeros. Now the display shows new pin number. If we want to change the pin number, we need to enter the new pin number and then press hash button. We are setting 1 2 3 4 as the new pin. Now we have pressed the hash button. Friends, as you can see, new pin saved. A message is showing on the display and it's also showing pin saved in the serial debugging on the monitor screen. This was our previous authorized number. Now let's take a look at the new authorized number. The previous pin was 4 zeros, which has now changed to 1 2 3 4. You saw the previous authorized number on the screen. Now the number has been changed and you can see it here. So now what we will do is, using the authorized number, we will send an SMS from the SIM card in the GSM module by writing on as the message. Friends, you can see on the display motor is stopped, which means the motor is currently in the off state. We will now turn it on. So to turn it on, we will send the command by writing on. The phone you see on my hand, this is the phone with the authorized number. I will go to the message option on this phone, and after going to the message option, I will type on here. It does not matter if it's lowercase or uppercase. I will send the message by writing on. The message has been sent. Look here, friends. The motor is running. The green light has turned on. Here we have not used any relay or magnetic contactor. We have simply connected an LED to one digital output pin of the logic board. When this LED is on, it means the motor is on, and when it is off, it means the motor is off. Friends, you saw that we turned on the motor using the on command. After turning it on, the GSM module sent me a feedback message, motor is running. So, by sending the message, you can understand that the motor is started. Now we will send another SMS from the authorized number by writing the off command. Now we are typing the off command. Send the message. You can see the motor has stopped and the LED has turned off. And we can see on the serial debugging screen the motor stop message sent, and just now a message has arrived on the mobile that says motor is now stopped. We received the feedback message, the motor is now running when we sent the on command, and the next feedback message we got was motor is now stopped when we sent the off command. So we saw that when the on command was sent, the execute function was confirmed through the feedback message. After sending the off command, the function that was executed was also confirmed to us through the feedback message. And we can also see the current status on our device's display. Friends, the small phone you see in my hand uses an unauthorized SIM. That means the SIM is not authorized with the system. So if I send a message from the SIM like asking the motor to turn on or off, the system will not execute that command, and the display will show unauthorized SMS along with the number from which the SMS was sent, and that unauthorized number will also be sent to my authorized phone, this phone, so that I can instantly know who tried to turn the motor on or off. Now we will send an SMS from the authorized number. Since the motor is currently off, I will now send an on command. The message has been sent. As you can see, an SMS has arrived from the unauthorized number. It is displayed on the screen, also show in the serial debugging screen, and a message has already been sent to the authorized number. Yes, the message has arrived on my authorized number. Now I will try turning it on to see what happens. Here you see the message unauthorized SMS from, showing the number from which the SMS was sent, but notice my motor did not start, so it was not possible to turn on the motor by sending SMS from the unauthorized number. So you can say this system is 100% secure because no one can turn the motor on or off and change the authorized number without knowing the PIN. Friends, those who already have minimal experience with this type of the task can easily build the device if they want. Although it's not a very simple task, with the help of the resource I have provided, you will be able to make it quite easily. So friends, this project offers a practical solution to turn your water pump on or off using just an SMS, and that to the 100% secured. If you enjoyed the video, don't forget to give it a like to show your support, share it with your friends, and subscribe to the channel so you can easily get all the upcoming projects. If you have any question or problem, feel free to let me know in the comment below. I'll be back with more exciting new project. Until then, stay well, stay healthy, and stay connected with the technology. Allah Hafiz.